My name is Juan Padilla, and I will be presenting the revision of a chapter in a geometry course on surface area and volume of solids. Geometry is probably the most visual topic in mathematics. This chapter covers the geometric solids, including prisms, cylinders, pyramids, cones, and spheres. The lesson is designed using the dynamic instructional design model proposed by Judy Lever-Duffy and Jean MacDonald in Teaching and Learning with Technology, and the direct instruction framework proposed by Madeline Hunter in Enhancing Teaching. To further enhance learning, technology will be used in the form of animated manipulatives to aid in understanding. The assessment is designed to elicit mathematical content knowledge, application of that knowledge, and clear explanation of the process, all necessary to demonstrate mastery in the current educational standards. Students in these geometry classes are mainly Hispanic American, with some African American students also present. Most receive free or reduced lunches, and a few have modifications to their learning detailed in individualized educational plans. All of these students have by this time taken geometry for 3/4 of the semester and are familiar with the vocabulary and expected norms of the class. SMART goals will be used to determine the level of learning the students have made. Students will be able to identify and name solids with 100% accuracy. Students will also be able to calculate surface area and volume of all geometric solids with 85% accuracy. This percent is due to the fact that most of the formulas for area and volume of prisms and cylinders are already known to most students since they have introduced early in the educational career. The difficulty lies in the formulas for pyramids, cones, and spheres. These require specific ratios, and ratios are difficult to recall for some students. Students are seated in a traditional classroom style, with the students facing the teacher as well as the board. The desks can easily be moved to create working groups if necessary. Students already know the rules and expectations required. Students will bring their texts to class every day and take notes accordingly. The book will be projected on the whiteboard to ensure that students are on task. Students are also encouraged to bring all construction materials to begin planning for the assessment. It is highly recommended that the constructions be done on a computer with graphing software to ensure accuracy. Students will take part in many hands-on activities that will support the skills needed to succeed in the assessment. They will visit the computer lab and use a website that will animate some of the concepts covered in the text to enhance learning. They will also be constructing figures that will be combined to make nets at a later time. A document camera will be used so that the instructor can demonstrate how to manipulate compass and straight edge to eliminate the need to use the whiteboard compass, which is manipulated very differently than the previous. Students have been made aware of GeoGebra, a dynamic graphing software also available free of charge. It has support material available to any user and created by other users. This software, along with the text, will provide the input. For this lesson, students will use a wiki created to demonstrate how to unwrap a polygon prism and illustrate how to work with a 3D object virtually. This eliminated the need to download GeoGebra to every computer. This also allows plenty of time for the students to discover and learn on their own. These interactions will be done at the beginning of each class session in the computer lab for at least 10 minutes at the introduction to each chapter section. Then a discussion will follow where students will make predictions of what values are needed to calculate surface area and volume and how figures are related to each other. Assessment is changing with the times. This assessment addresses the requirements set forth by the new guidelines. It is a project-based assessment that requires students not only to demonstrate content knowledge, but also to apply what they have learned by creating a net that can be folded into a solid. They must then explain how they plan for this task. This report must include the surface area and volume of their assigned solid. This assignment will be given at the beginning of the chapter, but the solid would not be assigned until the end. This will provide the anticipatory set needed to motivate learning. The final product should be a net that will be folded to create a rectangular prism of determined sides or a regular pyramid of determined sides. No student will be assigned a sphere, as it is rather difficult to accurately recreate with paper and pencil simply by folding. The grades will be determined by the rubric attached to the assessment at the beginning of the chapter. Using the DID model to design effective lessons ensures that learning is purposeful and each step is carefully considered to almost guarantee learning. It is further enhanced by using Madeline Hunter's direct instructional framework. Enhancing the learning using elements of visual literacy furthers the learning to yet another level. Though mathematics and visual learning are not the most compatible, they can be combined in different ways. The use of animations to augment learning has been an especially effective use of visual learning concepts. Though they may not be considered visual, creating manipulatives may be a sort of visual literacy. As with anything, it takes time to practice, and the last step in the DID model is to evaluate and revise the design. Thank you.